Hey chemistry students, today we're going to put our molar mass skills to the test and we're going to apply it to problems that involve mole and mass calculations. So remember, 1 mole of any substance is equal to its molar mass. So we are going to be reviewing how you calculate molar mass as part of our review. So how many grams are in 2 mole of water? So that's our first problem. We are going to need the formula for water, but just like a dimensional analysis problem, which this is what it is, we always figure out what our known is and our unknown. So we are going from mole to grams. So we do need to remember that 1 mole of any substance is equal to its molar mass, which we give in grams format. All right, so we're going to go ahead and start setting up. So we're going to start with 2 mole of water. All right, and we want grams of it in the end. So just like before, if we want to get rid of mole of water, it's got to be on the bottom here. And we want grams, so we're going to have grams of water up top. Now 1 mole of water is going to be equal to a very specific amount of grams. So here's where what we learned yesterday is going to come into play, where we're going to put in our molar mass. So water, it's H2O. Its molar mass is going to be equal to, so I'll write that here. Going to be equal to 2 hydrogens plus 1 times oxygen's mass. So it's going to be equal to, each hydrogen has a mass of 1.01 and each oxygen has a mass of 16. We plug this in our calculator, so 2 times 1.01 plus 1 times 16. 18.02 is what I am getting on my calculator. So there are 18.02 grams of water in 1 mole of water. So this is what we're going to be using in our problem above. So 1 mole of water is equal to 18.02 grams. All right, now our mole of waters are going to cancel, and our answer is going to give us grams of water. So we multiply our top numbers, 2 times 18.02. All right, and we divide that by 1. So it's just going to stay 36.04 grams of water. All right, problem number 2. How many mole are in 36.7 grams of lithium chloride? So here's lithium chloride symbol after I've crisscrossed charges. We're starting with 36 grams of lithium chloride. Let's be specific, and we want mole of it. So 36.7 grams of lithium chloride is our known. Our unknown is going to be, well, how many mole of lithium chloride do we have? So just like before, we know we want to get rid of whatever unit we're starting with. We're starting with grams of lithium chloride. So that means it needs to be on the bottom so they can cancel out just like our top ones did. And the top part is going to be our unknown. So we want mole of lithium chloride. Right? And we need the molar mass. It's going to be equal to 1 lithium plus 1 chlorine. So if I look up lithium's molar mass, it's 6.94 plus 1 chlorine is 35.45. We're going to add those two together, 6.94 plus 35.45, because I only have one of each. And I'm getting 42.39 grams per 1 mole of lithium chloride. So I'm going to put 1 mole up top. The bottom part is going to be this number, 42.39, because remember, this equals 42.39 grams of lithium chloride in 1 mole of lithium chloride. Two ways of saying the same thing. All right, our grams, one on top, one on the bottom, are going to cancel. We're going to multiply 36.7 times 1, and then we're going to divide it by 42.39, and that will give us our mole of lithium chloride. All right, and when I do that, I'm getting 0.8, let's round that 6 up to a 7. So let's do 0.87 mole of lithium chloride. All right, let's do 2 more. Okay, number 3. What is the mass of 2 mole of sodium hydroxide? So when it says what is the mass, it means how many grams. All right, and sodium hydroxide is NaOH. It has 1 sodium, 1 oxygen, and 1 hydrogen. So we're going to start by writing 2.5 mole of sodium hydroxide. We're going to set up our problem. We know we need to get rid of mole of sodium hydroxide, so we know it's going to be here. And we want mass of sodium hydroxide, and that's measured in grams. All right. We do need to go ahead and calculate the molar mass of sodium hydroxide. As stated before, it has 1 sodium, 1 oxygen, and 1 hydrogen. So 1 times sodium's mass is 22.99. 1 times oxygen is 16. 1 times hydrogen is 1.01. And then we're going to add all those together. Eventually I'll get it. All right, and I am getting 40. So there are 40 grams of sodium hydroxide in 1 mole of sodium hydroxide. So I'm going to put the 1 mole NaOH on the bottom and the 40 grams on the top. My mole of sodium hydroxide cancels. I'm going to multiply 2.5 times 40 and then divide it by 1 will just be this number. So 2.5 times 40 is equal to 100. So our answer is 100 grams of NaOH. All right, last one. Determine the mole in 25 grams of sodium chloride. Right, sodium chloride is just NaCl. We want mole. So we're going to start by putting our 25 grams of sodium chloride. We need grams of sodium chloride to cancel, so we're going to place that on the bottom. And we want mole of sodium chloride, so we're going to put that on top. We're going to solve for sodium chloride's molar mass, then we're going to plug in. All right, so it has only one sodium and one chlorine. So 1 times the mass of sodium is 22.99. 1 times the mass of chlorine is 35.45. We'll add these together. And I'm getting 58.44. grams of sodium chloride per 1 mole of sodium chloride. So we're going to have the 1 mole of sodium chloride on top, and then we're going to have the 58.44 grams of sodium chloride on the bottom. Grams of sodium chloride on the top and the bottom are going to cancel out. Then we are going to multiply 25 times 1, and then we're going to divide it by 58.44. So 25 times 1 is just 25, divided by 58.44, and I'm getting 0.4, let's round that 2 up to a 3. So we're going to put 0.43, and we don't just write numbers, mole of sodium chloride. So remember, you can come back to this video when you're working on problems by yourself. You can also look to see my old video on mole and mass problems that's posted on our Canvas site, and you can always send me a message in Canvas, or you can send me an email, and we will also try and have a video conference for you as well.